Hey everybody, let's work on factoring polynomials today. Okay, so what is factoring? That's a good place just to start. I think it's important to understand that all factoring is kind of like trying to undo multiplications or distributions. So for example, if I wanted you to factor 3x plus 15, I'm just asking you, what was this before we distributed? Before we distributed. So for instance, 3x plus 15 before we distributed probably was 3 times x plus 5. So factoring is pretty easy. We're just unmultiplying or undistributing. Now, factoring out GCFs is what this is up here. That's not something I expect you to need much help on. If you do need help on that, we can make some more videos on that. That's a skill you might already have. The thing that people do tend to struggle with is when we start factoring bigger polynomials. For instance, factoring trinomials. Okay, so what I would like to do is I have it typed here that I want to look at this factoring backwards. What I mean is, um, you know that I worded this just a second ago. Factoring is just the opposite of multiplying. So multiplying is the opposite of factoring, right? So let's just multiply and we can see where all the pieces come from. Okay, so if I'm multiplying x plus 5 times x plus 2. Remember how we do this is we typically would take the first term x and distribute it to everything in the second polynomial. So x times x is x squared. And x distributed to the other number 2 is 2x. So now the x has been distributed. Let's distribute this plus 5. 5 times x is 5x. And 5 times 2 is 10. Now we do have these like terms here that can be combined in the middle. 2x and 5x makes 7x. And so x plus 5 multiplied by x plus 2 gives us x squared plus 7x plus 10. That was a few lessons ago. Or actually that was just last lesson. We've already worked on multiplying polynomials. I think we can multiply. What we would like to do in today's lesson is go backwards. We would like to give you x squared plus 7x plus 10, and you tell me what the original polynomials were that were multiplied to give me that. Okay, so we're going to start with the simplest type. I want you to notice what we're looking at here is polynomials that don't have a coefficient out front. There's no number in front of the x squared. That's the easiest type. Those are always, if they factor, are going to factor into something like x plus something and x plus something. It could be x minus something, x minus or plus something, x minus or plus something. Depending on whether these are positive or negative, we will figure out how to tell what those should be. Let's see if we can figure out a pattern here. So let's just look at these two numbers, 5 and 2, and is there any way that they relate to 7 and 10? I see something. 5 and 2, if you multiply them, they give you 10, right? 5 and 2, the last two numbers, isn't that where the 10 came from? 5 times 2 gave us 10. So it must be, if we're looking at this, the last number should come from these two multiplied. Okay. What about in the middle, 7? Well, 7 came from 2 plus 5. Oh, 2 plus 5 or 5 plus 2, that's 7x, that's 7. And so the middle term is just the addition of those two numbers. So that's a nice pattern. Now this only works for when there's not a number in front of the x squared, when there's a no coefficient, or I guess I could say a coefficient of 1 when there's just a 1 there. This will factor into that. It'll be x plus or minus a number, x plus or minus a number, and I can figure out the two numbers by saying, okay, what numbers multiply to positive 10 and add to positive 7? Okay. So if we wanted to pretend like we did not just do this problem, and I say, hey, let's factor x squared plus 7x plus 10. Okay, now we're cheating. We know this is the answer, but pretend we don't know that. I'd like to factor this. We say, okay, good. Well, notice that, thank goodness, there's no number out front. It's just x squared. So I can just look at these two numbers, 7 and 10. Okay, I know that it's going to factor into something like this, x plus or minus a number and x plus or minus a number. Let's just find these two numbers. So what two numbers multiply to 10 and add to 7? So we can play a game. Let's list everything that will multiply to 10. Well, 1 and 10 multiply to 10, and 2 and 5 multiply to 10. Does everybody agree? What do those add to? Well, 1 and 10 add to 11. 2 and 5 add to 7. So which one adds to 7? The bottom one. So ding, 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 we have a winner. These two numbers must be positive 2 and positive 5, or plus 2 and plus 5. So we now see that x squared plus 7x plus 10 factors into x plus 2 and x plus 5. Could you check it? Yeah, all you have to do is FOIL or multiply this back out, and it should in fact give you what we started with. If it does not, you either made a mistake in your check or you made a mistake in factoring. So you can always check your factors to see if they multiply back out to what the original problem was. Okay, let's try another one. So look at this problem here. X squared plus 7x plus 6. Notice there's no number out front, so that makes me happy. I know this is going to be x plus or minus some number, and x plus or minus some number. Well, I need all the numbers that multiply to 6. That's not too hard. 1 times 6 and 2 times 3. Those multiply to positive 6. Which ones add to 7? 2 plus 3 is 5. 1 plus 6 is 7. So 1 and 6 both multiplies to 6 and adds to 7. So those must be my numbers, and they're both positive. Positive 1 and positive 6. So yay, I think factoring should hopefully feel pretty easy to you, especially if I can look at the middle number and the last number. Now, I've done everything positive. Notice all of our examples had been all positives. What if I start throwing some negatives in there? Well, just remember that the sign directly in front of a term that belongs together. So we're looking for two things that multiply to a negative 12. Well, that makes a little bit more complicated because to multiply to a negative, I'm going to have one negative and one positive. So we need, notice once again, there's no number out front, so we can factor this. So we need things that multiply to negative 12, and that, well, what number is understood to be there? They need to add to positive 1. And I have that listed here. Multiplies the negative 12, and we're looking for things that add to positive 1. So let's go through all the multiplications. Negative 1 and 12. Negative 12 and 1. Yes, I have to consider both varieties of where the negative could be. Okay? Those both multiply to negative 12. Negative 2 and 6, negative 6 and 2. Negative 3 and 4, negative 4 and 3. And those are all the pairs of whole numbers, or integers, I guess I should say. All the pairs of integers that multiply to negative 12. What do they add to? Negative 1 and 12 adds to 11. Negative 12 and 1 adds to negative 11. Negative 2 and 6 adds to 4. Negative 6 and 2 adds to negative 4. Negative 3 and 4 adds to 1. Negative 4 and 3 adds to negative 1. What was I looking for? I did not mean to draw over that. I meant to highlight. What was I looking for here? I was looking for positive 1. Which of these added to positive 1? Negative 3 and 4. So I could go with x plus negative 3 and x plus 4. Or what does plus negative mean? That just means the same thing as x minus 3. So I could go with x minus 3 and x plus 4. Hope that makes sense. So if you were to multiply these back out and say x times x and x times 4 and negative 3 times x and negative 3 times 4 and combine your like terms, you should get back this polynomial. So that's all factoring it. That's just checking. Factoring is pulling apart, going from this polynomial to these two polynomials. Okay? Are there any questions on that? Email me and let me know if you're confused on that. Okay? Now, we can step this up in difficulty, and there are many techniques, or I guess I will say there are 3 main taught techniques for when it gets harder. You don't need any other techniques for when it's this simple. Now, what makes it simple is just the fact that there has been no number in front of this leading term. There's only a coefficient of 1. There's not been a number there. So higher difficulty is if I add a number there, I now have lost that beautiful pattern. I now can no longer just look to see what adds to 11 and multiplies to 15, because these numbers are going to play a role in the middle number being formed. So the first way to do this, the lamest way, but the only way I'm going to dive in with you for now. Later, maybe we could talk about some junk in the trunk technique or factor by grouping technique. We're just going to do the lamest way, but the way that always works and is easy to understand: guess and check. Okay? That is the lamest way because it may take you the longest. It's not very systematic, or I guess it is systematic, but it's really boring. So here's how it works. The first term is 2x squared. So I know these first terms in these binomials are going to have to multiply to 2x squared. I know they each have an x. I just need to figure out what numbers multiply to 2. Well, lucky for me, the only things that multiply to 2 are 2 and 1. So these have got to be either 1x and 2x or 2x and 1x. Only possibilities. Then we look at the last term. It's a positive 15. So that means that these things need to multiply to a positive 15. Lucky for us, since everything is positive here, I'm either only going to have 1 and 15 or 3 and 5. Okay? So it could be 1 and 15 or 3 and 5, or 15 and 1 and 5 and 3. So what we will do then, since there are only 4 possible combinations, it's not hard to multiply these back out and check to see which one will give us back this original right here, which will give us back 2x squared plus 11x plus 15. So guessing and checking is a very lame way to do it, but it is not a difficult way. You just look at the first term, and those will have to be things, you will factor the first term for the first term of your 2 binomials, and you look at the last term, and then you have to try all the combinations of those. Okay, now if you multiply these back out, here's all the work for them multiplied back out. Only one of them will give you back the original problem, and that is it right there. None of these, notice they all have, let me highlight this for you, notice they all have 2x squared and a positive 15. They all have that because we chose all these combinations to make that. Where they are different at is in the middle term. Okay? And only one of them has the correct middle term. And that is the one that is the correct one. So if I wanted to factor 2x squared plus 11x plus 15, the answer for that is x plus 3 and 2x plus 5. Okay? So you can do this. You can do any level of difficulty with trinomials now, guessing and checking. All right. If there's no number up front, pretty please, it's easy to figure it out. If there is a number out front, hopefully you don't have too many things to guess and check. Now, I said this is the lamest method. There are some other methods, one called the AC method and one called junk in the trunk. Those are what high school teachers have named them, because high school teachers love having cute names for things. I don't want to focus on those too much right at the moment. I can show you those later if you would like to see them. Maybe when you move into Math 111 and you need some more help with factoring, you can drop by my office and ask me about those. But all we're really going to do on our test, we're not even going to do these high level of difficulty. We're going to stick to the ones with no coefficients out front. But I wanted to show you this just to kind of lead you into Math 111. Okay? But that is it. That's where I'm going to stop. I hope this makes sense. If you have questions, just send me an email. Bye.